base this objective of this is understand the concept of a tangent line approximation and compare the value of the differential dy. Everybody watch. This is important word. Differential what? dy with what? Actual change in y. So this is just physically you can measure with your tapes, okay? And this one you're gonna calculate using a calculus. Are you with me, class? And I'm gonna say, you know what? I don't wanna do this way always because they are what? Very similar. Their values are very close. It's easier to just use your calculus to do your work than physically measuring things, okay? To estimate the propagated error using a differential and find the differential of a function using differentiation formula. So we already know this one. I don't have to do this one again. Remember using this one to figure out Newton's method that we did. Are you with me, class? I'm not gonna go over. All right. Differentials. So, looking at this. If this is my first point x, and this is my second point x2. Are you with me, class? The difference is what? Delta x. Are you with me, class? Are you following me? Okay. So this is my y value, first one, and here's my what? Y value. So what's the difference in my y value? Right here. What's that called? dy. Are you following this picture? I want you to look at this picture carefully. Okay. So this blue line right here, that's your tangent line. Are you following me, class? That's your tangent line. And this is what? Black is what? This black graph is your real graph. Okay. So everybody see from here is my delta x. The delta x is what? x2 minus x1, in other words. This is my x1 and this is my what? x2. Are you following me, class? So far so good? Now, this is my, you can think of as y1. What is this one? What's this y then? y2. Am I right, class? So, the difference of a y is what? y2 minus what? y1. Am I right, class? So what's my difference? This much, isn't it, class? Right here is my dy. Does it make sense to you, class? Okay. Now I'm gonna erase the picture. So did everybody see my red color was my dx and dy? Are you following me? Yes. Now, my blue. Blue one is my tangent line. Are you following me? Okay. So from here to here. All right? So again, that's actually same. For the x is the same. The differences between x to x1, this is still what? Delta x. So delta x is still what? x2 minus x1. Are you following me? So delta x is the same. I moved that much. Now look at the tangent line. Tangent line is over here, and then the other one is where? Right there, right? So the f prime of c of delta c is this. Slope times delta x is this right there. Are you with me, class? So let's look at the problem. I'll give you an example. So they are very similar. What's the difference? You just told me this is my what? Delta y. Am I right, class? What is this one over here? That's dy. So they are very close, isn't it? Only difference is where? That much value. They're very close. So if I get my tangent line closer and closer and closer, what happened then? They're exactly the same. Are you following that? It's a numerical solution, numerical way of just figuring out things. Because a lot of times we don't want to just measure things. We want to do stuff in numerically using a calculus. It's much easier. So what they're saying is delta y is first one, this is my what? In other words, this is the same as what? X2. This is the same as X1 you can think of. Are you with me, class? This is your second value, this is what? First value. That's your delta y. And then what they are assuming is this delta y is the same as what? I mean, very similar to which one? F prime of x1 times what? Delta x. This is your formula. And use this to find your solution. What they claim is the differences in y, the change in y, is very similar to what? F prime of that first value times what? Delta x. The change in x. That's what they say. All right, let's look at the example. The example makes it so much clearer. So you have this. What's the formula says? Delta y is the same as what? F of c plus delta x minus what? F of c. And then we said that's very similar to what? F prime of c times what? Delta x. That's the claim, right? That's what we're using. So, y is, you can think of this as what? F of x. All right, I'm gonna write down everything you're supposed to know. So my f of x is x squared. F prime of x is equal to what? 2x. Does everybody agree? What else did they give me? They told me to start with this number. And they want to use this to be what? Dx. They said use dx to be 0.01. Starting value to be, in other words, c to be what? 1. I'm just using whatever they gave me. And then it says compare this with the dy with the what? So in other words, this is also delta x. This is a given. So when you do your problem, write down what's given. They gave you this, I can find this. This is a given, and this is given. So let's plug into my formula.
All right.
So delta y. So delta y, how do you find this? It says what? F of c plus delta x. What's my c? 1. What's my delta x? 0.01 minus f of what? C, which is 1. So that's the same as f of 1.01 minus f of 1. This is the same as then what? 1.01 square minus 1 square. So plug in your calculator, what does it give you? The difference is what then? 1.01 squared would be 1.001. Is that what it is?
Hold on.
One more 0, 1? 0, 1 times 0, 1 give you what? 0, 0, 1? Is that right? 1.001, right? Put this one, square this one. 1.01 times 1.01. What does it give you? Does it give you this?
Is it 0?
2 zeros, what do we?
Is it 0 dot? Maybe I did it wrong. But I got it 0
Put this in
dot.
your calculator, 1.01 square. What does it give you?
I got 0.0201. Is that right?
You said you got what?
I put in the minus 1 squared too.
Yeah, I don't know.
Oh, does it give you 201? Okay.
Yeah, that's
Oh,
what
yeah.
I got.
Thank you. You got it right. You did it right.
You did?
Yeah, you guys did it right. I didn't do it right.
Oh, man.
My calculation was wrong. So 0201. Is that right? Is that right?
Yes.
Did you say right?
Yes.
Okay, so that is equal to what then? The difference is only what? 0.0201.
Okay.
So that is my
That's
delta
your-
y.
That's the delta y?
So that's the only difference. So from this point to that point, the difference is what? 0.0201. All right, I did one way. Now I need to do what?
The other.
Differential y.
Differential.
Differential y.
Yeah.
So differential y is equal to what? This. F prime of c times delta x. So what's my f prime? this. So 2 times 1 times which one? 0.01. Oh, okay, this is the same as what? 0.02. That's my differential y. Class, can you tell they are what?
Very close.
They're close up to what? A tenth.
Yeah.
10 and 100th. The only difference starts where? Thousandth. Are you with me? Third decimals. Did you see that? The delta y is the same, very close to what? Differential y. So that's why, that's what we're gonna do. When you do some complicated problem, I'm not gonna go measure the difference of y, but I will do what? Differential y. I'm not gonna measure, but I will do what? Use your calculus. So your homework number 2.8 and 3.8, 3.9, number 2 and 3, this is what you have to do.